Good evening. My name is Dimitri Terrell, and I am studying in first year CSC and at NITPY. My roll number is CS24B1019, and my topic in physics is quantum computing and quantum information. How this quantum computing is going to change the world. How the principle of superposition and entanglement will give rise to immense computational power, and about quantum cryptography, algorithm, and other quantum technologies that can work in the future era. Now, let's leap into the two principles of quantum computing, that is superposition and entanglement. Well, what is superposition? Superposition is like simultaneous existence. If imagine if you have a bit 0 and 1, it can exist as 0 and 1. But in a quantum state or in a quantum mechanical level, the 0 and 1 can exist simultaneously. Or imagine a coin where you flip it to head and tail. But in quantum superposition, the head and tail can exist simultaneously. So this gives rise to an amazing concept of parallelism. Basically, if you have a maze and you want to solve the path for the maze, and what a classical computer will do is it will solve one by one by one, so that each path it will check, and finally it will arrive at a conclusion at a definite path. So that's what happens in a maze. So it needs to implement complex data structures, and you can just figure out the path. So if there are n paths or something like that, the time complexity will be to big O of n, or like it can be multiple combinations of paths, so it will take n square or n cube, so that the worst case is very high. But within quantum computer, the time complexity will be a constant, because all the paths can be simultaneously checked, or can be concurrently or parallelly checked using the principle of superposition, meaning the computer will check all the paths simultaneously so as to find the resulting path. And what is entanglement? Basically, when you entangle two particles, say an electron and another electron, electron A, electron B, and you entangle them both, and you separate them in an infinite distance, say at the edge of the universe and another edge of the universe. When you change one thing in one particle at one edge of the universe, the other particle also realizes the same change without any link, without any connection. The only link between them is entanglement, which is defying the every law of classical physics. So if you want to build a quantum communication network or the encryption method, basically these entangled particles, this entangled electron, can act as a decryption key and an encryption key for two systems. So if you have both the particles only, you can access the quantum information or a data which is secured in a quantum network. That's what it is about. So both superposition and entanglement can pave way to use technologies in this era. Next, the building block. The smallest building block is the qubit. The qubit is a bit, but it works in a quantum computer. Basically, classical computers have bits which is represented in the form of 0 and 1, but the quantum computers have qubits which exist in both the states. So the storage also, like in the classical computers, the storage is of the power of 2 power n, but in the quantum computers it will be 4 power n due to the simultaneous execution of superposition and quantum gates. Using the qubit, the quantum computer will run on quantum gates like the logic gates of the classical bits. See, this quantum gate is far more superior than the classical gates, and can use complex quantum algorithms which can solve problems very faster. And quantum coherence. Well, the preserving the state of a qubit is called quantum coherence. The ability of the system of the quantum computer to preserve the quantum properties over a particular period of time is called quantum coherence. Right now, the quantum coherence is just nanoseconds or something like that. But if the quantum coherence is increased, quantum computers can be standard issue. So it will rule the world. Next, we'll see that how quantum supremacy over classical computers works. Like, quantum computers can break the classical barriers. Basically, when we reduce the transistor size to a very, very small size, according to Moore's law, the transistor will start exhibiting quantum tunneling, which will disrupt every function of a computer. Basically, the transistor works as a one-way valve or one-way switch so that it gives out current or it switches out back. But if quantum tunneling occurs, the transistor can work any way it wants, meaning it will stop the working of the classical computers. So this barrier can be broken when we introduce quantum computing itself. Basically, transistor is of the size of 10 to the power minus 6 or minus like the micrometers. But if you use the atom, for instance, and if you utilize the atom, basically it is breaking the classical barrier and entering the quantum level. That will enable multiple functions. And it will also give advantage over classical computer, meaning if whatever problem that was impossible, it can be solved with a reasonable time frame with a quantum computer. And quantum supremacy is on the go. If quantum computers become standard issue, and if we solve the decoherence issue, quantum computers will become standard issue, and we'll be throwing the classical computers, all of the computers, all of the chips and data, everything will go into the dumpster. So the practical applications of quantum computing is infinite. You can solve problems like how to cure cancer, how the information theory or the black hole paradox works, how the time travel can be achieved. Everything is possible with quantum computing. Now, again, you have security data, you have cyber security within classical computers, you have cryptography. But when quantum computing enters, these classical cryptography thing and classical computer cybersecurity is just a piece of cake for quantum computers to break. Like our classical computers take encryption key and a decryption key, and if you want to hack the encryption key, you need to check out one by one what fits the encryption key and figure it out. This one by one is a time taking process. That's why we find hacking a little bit difficult. But if you take a quantum computer and hack the stuff, since it exhibits parallelism, the encryption key can be easily hacked within 1 second because of parallelism. So it's like solving a maze. So this can be reversed by using quantum cryptography. Quantum cryptography uses the principle of entanglement to create a secure communication. So two servers are entangled. This is the encryption, this is the decryption. If you want to communicate, you need to have both of them so that you can unravel the message within. So this will create a more secure profile, and classical computers cannot hack them. Even quantum computers will have trouble hacking this. So it's a very important process. And quantum key distribution, basically cryptographic keys, that is the encryption key and the decryption key, can be given to a particular person so that this cannot, like interception cannot be done. And the future of cyber security is built on quantum cryptography, I tell you. The sensitive data and protecting critical infrastructure and creating a huge security network will run on quantum cryptography only, because the future is more and more dangerous within the cyber era, and the only thing that can keep the privacy and the matter safe is quantum cryptography. Now, next will be quantum algorithm design. We have the quantum two major algorithms, that is the Shor's algorithm and Grover's algorithm. Imagine you have a complex situation where the classical computer takes billions and billions of years to solve this problem, but the quantum computer can effectively speed it up, like Grover's algorithm. You can detect, like there are unsorted databases, you have a significant, and you can solve this unsorted database thing using Grover's algorithm over classical search algorithm. This unsorted database, you need to sort them first and you need to search them in classical computers. But without sorting them, you can use the Grover's algorithm using a quantum computer and speed up the search process even without sorting. That's how quantum computers work. And Shor's algorithm, say for example, you have a 2048 number of binary bits, and you have to find the prime factor of those bits. The Shor's algorithm works, and in the quantum computer, if you plug in the Shor's algorithm, it will find out within seconds, because this can be used as this this can be used as a encryption method based on the difficulty of factoring. So encryption and decryption also works on based on Shor's algorithm. And quantum simulation. These simulations can be done for material science, health sciences, biological sciences, genetic problems, and physics, like black hole simulation, etc., 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 which can create huge opportunities in research fields. Basically, you can decrypt the mystery of the universe to the mystery of the Planck length to the mystery of the black hole information paradox, etc., etc. This just goes on because of quantum computing. Uh, gosh. Now, quantum internet. This is a future secure communication beyond classical internet. Like the quantum internet is still in its baby stages, but it can be fast, it can be brutal based on the principle of quantum mechanics. Like you can exist simultaneously, right? So it can be very fast at every place, and entanglement will give a secure channel how it can run, and communication can be transformed by using data exchange or something else. This can work to implement new and financial approaches when quantum standard computers are standard issue. Lastly, quantum computing applications from finance to drug discovery. When quantum computing, using quantum computing, finance can be used, and in the finance string, the stock market can be predicted using the quantum computer. Basically, stock market is like a it's like a very long process, and you can predict the stock market, how it will turn out, how it will run based on the quantum computing, financial modeling, and optimized investment strategies. Medicine, the drug discovery and more effective therapy and personalized medicine can be done using quantum computer. Quantum computer can also work in material science, like it can simulate what kind of problems it can have, and it can also enhance energy storage and electronic ways of communication, and electronic systems can be optimized using quantum computing simulations. And for AI, basically we have AI with the classical computers right now, and we know that AI is running right now, even at if it is 35%. But if we enhance it, if we want to enhance it more without the quantum tunneling effect that is seen in the transistors, you use quantum computing with the machine learning algorithm, you get a more powerful, effective AI. Imagine if the AI feels such a, what to say, imagine if the AI feels emotions. Imagine if the AI can generate emotions and can withstand the high computational power. This can be done using quantum computing. So these are the applications and the challenges in quantum computing. Basically, whatever technology we have, whatever technology that is present, is always facing a challenge, irrespective of its applications or its huge conquering application. So technological challenges. You have something called what is called decoherence. Basically, when quantum computer interacts with the basically when a quantum computer interacts with the outside environment, or when it interacts with itself, it undergoes two major phenomena, that is interference and decoherence. This remains a significant challenge. Because of this, the quantum computer wave function only remains as a matter of seconds, or nanoseconds should be exact, not matter of seconds, nanoseconds. This will create a real world problem, and to overcome this, scientists are still finding solutions. Like topological quantum computing was used by Microsoft to figure out this, and the elevation, the state about the state of time to which the qubits survive was a little longer. So we need more suitable, like suitable more solutions. And opportunities are, quantum computing holds immense potential to revolutionize every industry there is, even remove industries that aren't useful in the 21st century. Like if you take a financial brokers or stuff, you can remove them using quantum computer and AI. If you combine them both, you get a financial modeling and optimized investment strategies. You can remove the broker industry for, like, throw it out. If you want to fix a marriage, you can use quantum computer to figure out how many possibilities are there around the world, and you can just optimize it. That's how the system works. The journey towards quantum computing is a huge endeavor, but it can be done. It can be done soon enough to solve the most pressing problems of humanity, the most pressing problems in science, the most impressive and pressing problems in all of the universe. That's how quantum computing is, and that's how it will work.